Hi everybody. In tonight's Unity tutorial, I'm going to go over making a spline inside of Unity, and then the spline we're going to calculate just how hard the spline is turning, and that's the part we're going to do, calculation and how hard the spline is turning. It's not a long tutorial, it's a quick one. All right, so let's add a floor. All right, just a couple of things so we could see the distance, right? Now we're going to draw a spline. You need to get the package. So let's go to Windows Package Manager. So we just go to Unity Registry and we type in the word Spline, and then we'll install that. Okay. Now I could go here and say right click, Game Object, and I should see Spline. And I'll just use the Draw Splines tool. So here I'll click my first spline knot, then I'll click one over here, and I'll just click out like a spline path. And then I click and I connect. So I drew my spline. Now I'm going to have some code. Create monobehavior script. I'll just call it spline. Drag and drop the script onto the object. And now let me double click here to edit the script. So let's see. We're going to get the spline container object, and we're going to evaluate some points around the spline. We're going to let the person put in the precision of how fine to evaluate points along the spline. And what else? Oh, then we're going to have a list of points. Every time we evaluate a point along the spline, we're going to have to store that in some array. Let's make a class that's going to have everything that we want. So here's the class that we'll make. We'll have the float t. T is like time and what time along the spline. Position is like when we could evaluate a position on the spline and get an actual point in 3D space. The tangent is like at that point, which direction is the spline moving? Then acceleration, from one point that it was pointing this way and to the next point that it's pointing this way, like how much is the spline changing direction? And then I just wanted to point to the left and the right. Cross product helps us get the curvature, and this anew. And now I'll just make a public list evaluation points. We got some red squigglies, so let's put the mouse on them and see what it says by adding the using system collections generic. So we'll do that, and the red squigglies go away. Let's come back in here. This is the spline container object. And I just want to drag and drop that right here so that in the script I could manipulate the spline. All right, let's start writing something else next. Private void test. And then we'll call our little test function from start function, private void start, then we'll call test. So in the test function, actually, let's call this evaluate because that's what it's going to do. So in this eval, what we're going to do is we're going to have a loop where we're going to loop the t values. We'll make a new evaluation point. We'll get our position by doing an evaluation of this evaluate position at t. And then we will add that point object to an array. And let's see how that looks. So we'll do a private on draw gizmos. And in there, let's do a loop. Then we'll do okay. So now when this code runs, it's going to evaluate a bunch of points, and at each point on the on-draw gizmos, it's going to show a wire sphere. And you see we got a bunch of spheres along the way, and the color is white. All right, so we got the spline points. What else could we get? Let's get how much the spline is changing. All right, so let's get the point dot acceleration. It's going to equal spline container dot evaluate acceleration at t. And now in the gizmos thing, let's draw something to see the acceleration. Let's draw a line. And we'll say gizmos dot draw line. Okay. Boom. Save. So let's go ahead and see that. Whoa, so the lines are pretty big, but you can see that they have a height, right? So I could just scale down the height of those lines. So magnitude, so instead of 100%, we could say like 0.2. All right, cool. So you see everywhere that the curve is turning more, the line goes higher. All right, so we got the acceleration that we could see with those yellow lines. We got the positions we see with the spheres. Now we know it's turning, but we don't know if it's turning left or right. So for that, let's go back to our evaluate function. So if I have the point before and the point just after, I'm going to make up the point before and a point just after. So I'm going to have a value called delta. And why don't we leave the delta to be equal to our precision? I will figure out a t in front, and I'll figure a t behind. I'll get a tangent forward, and then I'll get the vector 3 for the tangent back. Okay, so I got the tangent here, and then I got a tangent over here, and then I guess like how the tangents are changing, then I could tell something about which way is it going. So to get that comparison between the two tangents, I'm going to get a cross vector. So point, that's what my point crosses in my evaluation object, is going to equal vector 3 dot cross, and then I just give it the two tangents, tangent forward, tangent back. It always helps to spell nice. So the cross value, it's a vector, and of the vector there's the x, y, and z axis, and I'm concerned with the y axis up to determine if it's going left or right. So now to tell if it's going left or right, I'll just use the if statement. Okay, so now I got my left, right. I can tell if it's going left or right. Okay, so now in the gizmo thing, let's take a look at that information. Then, oh, here's one thing too. The actual ball, the position spheres, let's move this up here. Okay, boom, 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 boom. For the left, we could say that the gizmo color, we could set it to something. And if it's going to the right, let's say that the gizmos dot color equals color dot red. And then we'll draw the sphere. If it's blue, we'll draw that sphere in blue. If it's red, we'll draw that sphere in red. So first, let's just see that. And there you go. With the knots, I could tell it goes from 0, 1, 2. So that means the spline's going in this direction. So as it's going in this direction, you can see red, red. Wait a minute, what's up with the colors? Red was supposed to be, it's turning to the right. I think I got something flipped backwards here, because this is turning to the left. It's turning to the left. And then over here, you can see it goes and it turns the other way a little bit. So then the balls are that color. Then it's turning to the left again. So why are my colors wrong? I got my left and my right mixed up. How did I do that? Here I said if the y is greater than 0, that's going to the right. If it's less than 0, then that's going to the left. Maybe I got that backwards. It's okay. Left, right. Okay. So blue is, what do I say? Blue is turning to the left. Yep, turning to the left. And red is turning to the right. Now let's like draw a line to the left or the right of each position. So I could use some information. I need a left line and a right line. I'm going to need the point dot tangent to get the left, a point to the left and a point to the right. And then I'll need a tangent. Okay, so as you're going along the curve, a tangent is a line that's going in the direction that the curve is heading. It just keeps going out in the direction the curve is heading. So from that tangent line that's going out from where the curve is heading, I can get a perpendicular line that goes to the right and the left. And then here in the gizmos, I can draw a line to the right or the left. So it'll be gizmos dot draw line. And it's always starting from the point dot position. And then the second point is going to be the point dot position plus something, plus the point dot left. Going to the right, same thing. Let's see what this looks like. Okay, the lines are pretty long. So let's see in the scene here. I'm turning this way, so I'm turning to the left in the blue. So the lines are pointing to the direction I'm turning. All right, that looks about right. Whatever, but this is like just how to get that information. Anyway, that's the end of this tutorial. Thanks and have a good day. Bye.